Hello, Honors Trig and Pre-Calc. That's a little song I made up just for you. We're going to talk about section 4.1, angles and their measures. So let's start by looking at what an angle is. You probably have seen one before, and when I say probably, I mean definitely, right? You've all taken geometry. An angle has three pieces. It has a vertex, and then it has two rays extending forever in both directions. But in pre-calc, we are going to be a little more specific and say that these two rays, these two sides of the angle, have what we call an initial side, basically where it is starting, and a terminal side where it ends. Notice this angle is, I'm able to decide which side because I'm looking at where it starts and where it ends based on this little arrow. It's kind of like opening up. In pre-calc, we take angles, like just any angle, and we fit them to our XY coordinate plane. In geometry, you kind of just looked at angles like in space, right? Just hanging out on a page. But here, we are going to say, okay, here's our XY coordinate plane with quadrants 1, 2, 3, and 4, we are going to take an angle and fit it to this. Specifically, standard position of an angle is an angle whose initial side, oh my goodness, that was really bad, whose initial side is on the positive x-axis, and the angle opens counterclockwise. So it could look like this. This is an angle in standard position, where again, its initial side is starting on the positive x-axis, and it will say opens up, kind of, or counterclockwise. Oh gosh. This kind of angle will be a positive angle. It will have a positive either degree or radians, and we'll talk about that in a moment. If I draw an angle and I still start on my positive x-axis and I open down or clockwise, so this is open down, or if I'm moving clockwise, that would be a negative angle. Negative angle measure. And we will look a little bit more at that in a moment. In your previous study of angles, you often looked at an angle by considering the points on the angle, right? We said, like, here's point A, here's point B, here's point C. So we could name this angle ABC. And while that is correct, that is not how we are going to be naming angles in pre-calc. In pre-calc, we are going to name angles using Greek letters. So for example, one of the most common is theta, this little guy right here. And it's going to be represented by just like kind of standing inside the angle. The others we might use are alpha. We could also use beta. There are other Greek letters, but these are honestly like the most common that we'll use. Specifically, theta is a real big one. And the second question is, do these angles have a measure? Yes, of course they have to have an angle. Excuse me. Yes, of course they have to have a measure. So there are two different ways we can measure an angle. We can measure an angle in degrees, or we can measure an angle in radians. If you think about it, this is not any different than any other form of measurement. I can measure myself in inches, I can measure myself in feet, I can measure myself in meters, right? There's different things I can measure with. Similarly, I can do that for angles. So what do we know about degrees? If I have an angle and it goes all the way over here, how big is this angle? If it's a line, this is 180 degrees. If I go, let's say, all the way around, that would be 360. And that means, any other thing is going to be kind of one of those numbers, right? If, for example, I ask you to draw negative 45 degrees, okay, well, now let's think about this. I'm going to start on the positive x-axis. I'm going to be moving down because it's negative. If I know the entire thing is 180, that means half of it is 90. That means negative 45 degrees would be right here. Degrees are probably the easier of the measures to know and understand because we've been working with them for a while. Radians is going to be slightly different, but that's okay. We got this. Radians are looking at the ratio of the radius of a circle to the arc length of the angle it intersects. So what the heck does that mean? Let's draw a picture. That was not a very good circle, but forgive me. So radius of the circle, we're going to call r, right? That would be like this is the radius of the circle. Okay, sorry about that. And arc length, we're going to call arc length, where is this right here? S. I don't really know why they call it S. I don't remember. But let's say my angle I'm interested in is about that big. Let's say this is the angle I'm looking at. The arc length is this measurement right here, S. Theta, the angle measure, is equal to a ratio of our radius and arc length. So in this case, we could take the arc length divided by the radius. Notice in my drawing, specifically, like, let's assume in my drawing, because it kind of looks like that, let's assume S is equal to R. If that's true, which we are going to pretend for this picture, then its ratio is 1. Or in this angle, in this drawing, we have an angle that has a measure of 1 radian. Ooh, sorry. Let me rewrite that. This angle here has a measure of 1 radian. Now you might be thinking, okay, that seems really weird because that's definitely not 1 degree, right? 1 degree is a really small angle. Well, again, radians and degrees are different measures. If I measure myself in centimeters, I would seem significantly bigger than if I measure myself in meters. And that's the same idea here. Let's think for a second about circumference of a circle. Circumference of a circle. Maybe you remember a circumference of a circle to be 2 pi r. So that means this is an arc length, right? If I'm thinking of it, it is the arc length of an entire circle. Oh, that was a really bad circle. So let's consider how many radians do I have in an entire circle? Well, theta would be equal to this 2 pi r, that arc length, divided by the radius of our circle. Notice, r and r can cancel, and what we just found out is that there are 2 pi radians in a circle. This is, like, honestly, the biggest thing from this lesson that you need to know. So if nothing else, if you learned nothing else today, remember that there are 2 pi radians in a circle. What does that mean? Well, if I have this angle right here, which we know is 180 degrees, I could also say, well, it's half of a circle, so this is pi radians. Nice. This is very exciting. And the next question is, can I convert between the two? And the answer is, of course, yes. Just like I would say 1 foot is 12 inches or any other measurement, I can say 180 degrees is the same as pi radians, or I can write that as pi over 180, depending on like what you're trying to cancel out, right? This is going to be like a unit conversion type problem. Don't stress when you hear those words. I could also write this as 360 degrees divided by 2 pi, because that's how many there are in a full circle, but we would simplify that because we're really smart and we divide everything by 2. The last thing in this section is called degrees, minutes, seconds, and it's more, how do I say this? It is more accurate measures of degrees. So I'm going to start by just saying that the symbol for degrees is this little circle, right? The symbol for minutes is one little like apostrophe, and the symbol for seconds is 2. Let me make that clearer. And the ratios are that for 1 degree, there are 60 minutes. For 1 minute, there are 60 seconds, which means 1 degree is 3,600 seconds, right? I would use this unit conversion right here, technically, to get over here. We will look at all of these facts and some more on Friday, but thank you for watching this video and taking these notes.